So doing a code analysis problem might sound complicated, but it's what we've been doing every single week in class. So let's make a little project here. We'll call it practice code analysis. So I'm just going to bang off a quick problem. And the question I'm about to show you is of about the complexity I would expect you, even for today's quiz, to be able to do, because it's going to be pretty simple. I'll say new, Java project. Actually, I've already made my project. I have to make a class now. So right click and class, new Java class. When we're together at school, I have a practical component. During the final exam, students actually have to fire up Eclipse and write a program. Here you just have to sort of think about it. So here my class name, we'll call it main application. And we'll let the computer generate public static void main. And we'll try running it up front to make sure everything is set up properly in our environment. Yeah, no problems. That's good. Now, another good study resource is my fabulous Mindmap, right? So let's call up Mindmap and we'll show you the couple of key things to look at there. And I'll give you an updated link to it. I've made some additions to it. Whoops, I just upgraded. I have to go to the older version. I haven't migrated this map over yet. Okay, we'll just finish up this little bit. And then I will start to talk a bit about UML. I'll give you a break and some lab time by yourself, and then we'll go through the UML. So what we're talking about here is analyzing an existing program using UML and generating code from a UML diagram. If it sounds complicated, believe me, it's really not. Everybody else gets it. You'll be fine on it. P-Data Mind Maps Java. Just migrating stuff up. I just upgraded to a newer version of Mind Manager here. Yeah. So in terms of this, and let's kick out a link so you have it to start looking at. And keep this link handy, right? This is actually the basis of a book I'm writing because I don't really like any of the Java books that are out there. They're either too simple and procedural, they just teach you how to write code, and they don't talk about architecture and design, or the books that talk about architecture and design are at too high a level and they're not accessible to kind of new learners to Java like yourself. So I'm trying to write a book that bridges that divide. So anyway, keep this handy. It may help you in the future. So we'll say share. Also, I'm just going to leave a note to myself to remember to talk about variable scope and visibility. So here in the mind map, which you now have a link to, you can view this in a browser. I would especially focus on the recipes, right? How to write the basic Java program, static and instance, that's going to be a big one. What does it mean? How do you apply the code to it? Maybe give you some code examples on that. Understanding the difference between primitive and data objects, right? Think about the von Neumann architecture. Visibility, so that gets to this concept here of scope and visibility modifiers. Private, public, right? You got to know the difference between those. How to make an object, well, that's just basically the new operator. Four types of variables, right? That's a major X-man power in terms of being able to help you analyze the operation of a program. It's all there, right? We've done it. You know it. You just need to go back and maybe think on it a little bit and put it together. So anyway, yeah, pay attention to that. And let's go back to our little sample program now. I got to make this bigger again. Let me check back to my meeting to make sure we're all still here. Yay, we're still here. Great. I haven't lost anybody yet. Oh. Okay, guys, I don't know why I'm having a thing finding the fonts. So I'm going to do this in Sublime. I'll bring it back here to do the to run it through the debugger. I don't want to spend more time on this. So we'll develop our code here in Sublime. So we'll call this final exam, and we'll share this out with you, final exam. I don't know, practice code to study or something. So contemplate now a simple program which might look like this. So I might mess you up, right? And during the final exam or even today's quiz, I will be on the meeting during the exam. Send me a private chat if you have any questions. Don't go in the public chat and say, Peter, question 5 is wrong. It won't work. I'll be like, will you shut up? That's part of the question to figure that out. So if I give you a code sample and I say something like this, well, no, that's in Java we say system dot out dot print one. So here's your question. What is going to be the output of this program? Right, that's your question. You're going to be asked that. Why didn't, oh, there we go. What is the output of the program I just screenshotted to you? Let's see who fell for my little trick. It's not hard, guys. Think about programming rule number 1, programming recipe 1. How do we construct the basic Java program? Think about the Java language specification. It's all there. Ah, why, Subhash? Yeah, exactly. That's programming recipe 1 in my fabulous mind map. Your program must contain exactly one, and not more than one public class, and the name of that class must be the same as the name of the file it's contained in. Excellent. All right, you guys are good. So you caught me on that little trick. So let's fix this up now to make it proper. So here my file is called main application. Main application. So your program, I might ask you to write this, or I might show it to you as a screenshot and to tell me what's the output. So here we'll say class calculator. So let's declare a method. So what's going to be the output of this program? All right, guys, let's just do this little example, then we'll go and take a break here. So what's going to be the output of my program? Oh, so Joe Me, do you think if you don't like my program, can you do a better job? Let's make that a class exercise. We'll take a 15-minute break. I want you guys to work on that and make it so it works properly, and then we'll look at it together, and then we'll do our UML, which will count as your assignment, right? So, and this is a great class, right? Because now we're talking at a very high level. This is like an intermediate level class now. Because at the beginning, I had to spend so much time just showing you a basic for loop, but now you know that. Now we can have an interesting adult conversation. So anyway, let's take a break until 9:20. Very good, Jomi. Don't tell anybody. Let them figure it out by themselves. Don't share. Because this is not for marks, right? Nobody is even going to see what you're... All right, guys, it's 9:20. Let's pick it up again. And by now, I think probably all of you have figured this out. So to begin with, int is a valid return type, but input is not a valid return type, and we sort of got that because our code linting caught it, but that's an easy thing your eye might slide over. So you need to have valid return types for your variables and your methods. And similarly, this method is not properly constructed. So at least it needs a return type, and we need to make it public if we want to access it from outside of this class in our main application class. So public int, return type, method name, and properly formulated method signature. And now that should be okay. I'm not sure why my color coding is not working there, but anyway, input A, I guess, is okay. So this should correctly work now. Let's give this a spin and find out. And once again, I'm not sure why I'm not able to see how to change my font size today. What's going wrong with me? Oh, actually, I do have some error, but I'm just going to try and see if I can get this screen sharing properly. So font, appearance. Yeah, I don't. That's from Git. We're not using Git. So my font setting should be in here somewhere. Oh, I think I forgot to go to Java before. Maybe that was it. Java editor. I think this is the thing where I set the font. Okay, good. I got that to work. Now here it's complaining that the error is what exactly? Oh, I just something simple. I forgot the semicolon. I'm not going to catch you up on a semicolon. That's kind of a stupid little nit to pick. But I will expect you to understand the good structure of a program. Now, the big goal of this course is to get you guys set up for your next Java course, which is constructing web applications. And if you come out of this course understanding all of these basic structural elements, I mean, web applications is kind of complicated, but at least you'll hit the ground running. You'll have a pretty good firm foundation on it. Now I think this program should run, so let's run it and see what happens. Yeah, the correct answer is 4. So we missed a couple of things there initially. We did not give a valid return type for our variable, and we did not properly construct our method. So anyway, now let's amp this up a little bit to see something else you might get here. Just put that stuff aside for right now. We'll make another class called practice. And we'll make a for loop. Now here would be another thing I might catch you up on. The problem here is we have code which is not contained in a method. And we've been saying that you can't have code floating around in outer space, so always needs to be contained in a method. Now here the problem is I did not correctly close my brackets, so this class believes it's inside class calculator. So let's go and fix that up. And again, I'm not going to catch you up on something like this, which might be kind of hard to see when you're under stress in an exam. So I won't do something that's kind of like a little nitpicking thing, like a missing bracket or a missing semicolon or something. But I'll show you what I will expect. Here again, I forgot a semicolon. So I might say, I might say, what would be the output of this program? So every time we walk through our loop here, see, that's our for loop. Let's just dump out the variable of what j is. So now the question is, what's this program going to output? So you have to trace the value of j. That's a little bit complicated, but I think it should be something. Just keep a little piece of scratch paper beside yourself when you're writing the test, and then you can then you can trace that out. I don't think that's too much. Oh, j cannot be resolved to a variable. Why? Because think about four kinds, and that's actually a problem I might give you. Because if you think about the four kinds of variables, you know that j only has a meaning within this loop. So class instance, class static, method local, or loop local. So here j has meaning only within this loop. So outside of the loop, it's correctly telling us I don't know what a j is exactly. So what would be a way to get around that? We could promote j to being either a class instance variable or a method instance variable. So let's dimension j up here. And if we do that, we have to be careful to not put the int again there. Because if I put int again there, I would now be making another variable which could have the same name, but it would be in a different frame, right? In the stack, in the Java stack frame, right? In the call stack, it would be a different variable. So if I wanted to mention j there, I have to not dimension it again there, or I would. Now this would run, but the output, it would probably say something like uninitialized. So it's giving me duplicate local variable in that case. So again, let's fix that up by getting rid of that and run. And the output is 6 in this case. So you would have to trace through. I'm not going to do it, but I will ask you to do it. Just play computer in your head and write through. So when you go through initially, j is 0. Is 0 less than 5? Yes. Well, it's going to execute one time then. And then we're going to increment, so now 0 becomes 1. But here we're doing another post increment, so now j becomes 2. Right, so then just keep looping through it. So now it's going to say is 2 less than 5? Yes. So we're going to increment j again, but now we're going to increment it again, so now 2 becomes 4. And the third time through, j is now 4, so loop will execute again, but now j is being bumped up to 5, and now j is being bumped up to 6, and the correct output is 6. So I might ask you to write a program of this level of complexity given the explanation of it, or I might ask you to trace, to give me to say what's going to be the output of this program, right? So that should be okay, I think. So let's capture that into your PowerPoint so you can go and review that. To make sure I didn't kill anything, I didn't end the meeting or something when I plugged in the new cam. No, I guess we're all here and I'm sharing my screen and everybody should be ready to go. So let's go. So unified modeling language is very simple and it's a very natural way of thinking about programming if you understand objects. And one of our learning outcomes here is to reinforce the concept of what an object is and how objects communicate with each other. Give you more of a hands-on feel. Give you more. Give you more of a hands-on feeling of what it means to say that an object models a thing in the real world. That's going to be a final exam question, by the way. And that computer programs are communities of objects. That's going to be a final exam question. Which interact together to simulate business processes. Now, we don't always have to simulate business processes when we're programming. You can write a game, right? Games programming is a big thing. But in that sense, the game is sort of the business process. I mean, it's not really a business. It's a game, like the character is trying to, I don't know, put a ball in the hoop or something. But it's still an implementation of some algorithms. So we'll say, or to implement some algorithm, some desired outcome. You know, so it could be a business process or it could be a game. Those are the two. Or the other thing we do with computer programming is numeric analysis. Like if you're in engineering, you can write programs that are just basically big complex calculators to maybe take millions of data inputs and calculate them. So those are the three things you could do with computer programming. Simulate business processes, make a game, or some complex numerical engineering type calculations. But in all three cases, you are implementing algorithms, which are sets of instructions of things to do, or implement algorithms. So in all cases, we take some input and we apply processing rules to the inputs. This is the general definition of computer science. If you read any first-year university textbook on Chapter 1, what is computer science, that's what they're going to tell you right there. We take inputs, apply some processing instructions, which are our algorithms. This sounds like a really good final exam question to me. I like this. I'm going to use it. Oh, I better not say that out loud. I don't want the students to hear it. Take some inputs, apply processing instructions, and present outputs to deliver the final result to user. All right, good. Let's go and do that now. So our goal here for this UML, which I've already said, but I'll say it again because if you repeat something a bunch of times, maybe you understand it on a more deep level. Is to create the design from which we will generate our FizzBin game. Now, you might have thought, or maybe in some earlier courses you've taken, you might have been given written instructions on creating a program. In other courses, you probably received written instructions for writing a program. And you probably found that this is a very inexact and very hard to follow, right? It's very hard to go from written instructions based on written text, because language, talking is for art, philosophy, music, right? Culture, I love you, love poetry. But if it's for specific technical things, it doesn't really convey the idea very well. Which is why what you're going to be doing at work, this is the way we do things at work, when you receive a specification, so they give you a specification for a program for the requirements, and you create a UML diagram, and then you show it to your manager. You say, is this what you want? They say yes or no, or they change it, or they make requirements to change it or something, and then you generate your code from UML. So let's do that together now. And it's Unified Modeling Language. That's what it stands for. And bear in mind, even though we're not really going too deeply into software engineering in this course, this is the basis of what they call agile software engineering. So you're learning that too. Now, some of the things we think about, as we said here, are what classes do we need and how do we join them together. And we've already figured out that it could be method calls, or it could be compositional relationships based on field names. So let's go over now and start doing this together. So here is my tool. By the way, for your assignment, how do you hand this in? Some students have heard about things like Rational Rows, which is a case tool, computer-aided software engineering. I really wish if you would not use that stuff. Yeah, you can go and download free trial versions of it and stuff. There is also Visual Paradigm, but you're going to spend too much time playing with the computer and not enough time penetrating your thinking into the problem you're solving. So just so you know where we're going, how you're going to hand this in at the end. All right, it's 10 o'clock, and we actually have about 50 minutes, right? In about 50 minutes, we're going to take a break before we come back and write our quiz, but this will be enough time to get this done. Because the whole purpose of UML, it should be short and concise and to the point. You don't want to write pages after pages after pages, because that's not the point. The point is to make it short and concise. So how to hand this in? Yeah, you can do this in groups. Somebody's about to ask me that, I think. So yeah, work in groups. But make sure everybody in your group is doing the work right. You're not helping anybody if you sort of let them slide along without working. Now, you can hand it in any format you like. I suggest PowerPoint, or if you don't have PowerPoint, you can get Google Sheets, which is the freeware version. If you want to use Word, okay, well, whatever you like, but I think PowerPoint's probably the most easy to work with. I recommend PowerPoint or Google Sheets. If you send me Google Sheets, please make sure the link you send me is public so I can actually get into there and view it. Right? Students send me links, and then I get into it. It says you don't have authorization, and then we have to waste a bunch of time fixing that. So if you send me a link to an online service, make sure it's a public, viewable by the world. So I recommend PowerPoint or Google Sheets. Now, in terms of how you're going to get this diagram in, because you're going to be drawing a picture here, so I suggest drawing your diagram on a piece of paper, as you're going to see me doing right now, and we have the Camtasia video besides the standard classroom video. and then take a picture of it with your cell phone. Everybody has a camera phone these days. And then upload that. And if you need me to tell you how to upload it, I can demonstrate that. But I think you guys are pretty good with things like Google Drive and stuff. You can upload from your phone to Google Drive, then you can grab it and copy and paste it over to PowerPoint. And there's tons of good freeware screen capturing programs out there from NHC Suite and stuff. Again, if you need me to demonstrate how to do that, just let me know. We'll step through that. I suggest drawing your diagram on paper. Take a picture of your paper and embed or copy paste it. Embed the picture, the image, into your PowerPoint. So let's go now. So our goal right here is the Fizbin game. And what does the Fizbin game want? Well, if this was the first time I'd ever showed it to you, we'd talk about it in a fair amount of detail, but I think you guys already understand. And you've already done some stuff with Fizbin, right? We did that towards beginning of class, so you can, and next week we're going to take the whole code right from the beginning. I'm going to basically give you 95% of the project code. You'll just have to write a little bit to link the things in together. But what does Fizbin card game need? And if I'm going too fast, just go in the comments and I can go and repeat it more, but I'm thinking you probably remember it. So we need what kind of objects do we need? Here's a good heuristic, a good software design question to ask yourself. What kinds of objects? I'm just going to close the curtain. I think the sunlight is washing that out. You're probably not seeing it. Hang on. Okay, we'll give ourselves a quick 5-minute break in a few minutes, not longer than that because we have to get the quiz in there too. But I'll just give you some stuff to start thinking about. So what kinds of objects? Now, one thing I used to do at IBM, and they actually recommended, if you read Martin Fowler's book, UML Distilled, which I put up in the informatics directory, if you'd like to go and get some enrichment material there. But a lot of the big experts, what they say is to use these, which are little index cards. You can get at any dollar shop, or you could just even take a standard like 8x11 sheet of paper and cut it up. But it's kind of easier. The purpose of UML, it should be a tactile modeling system, right? It should be something you can feel, you can actually handle it, and that gives you more feeling, insight into the system you're designing. So I think we need a card, right? We need one card. And I think we also need an aggregation of cards, which we're going to make probably an array list, I think is a good way. So we need a deck of cards. Do you see now? Hopefully you're getting more of a feeling of what we mean by composition in Java. And if I had different colored cards, that would be better, but this is what I have right now. So deck of cards. And we can make little notes to ourselves as we're going along. So we'll say, well, array list is pretty good. We'll probably have our array list will be an array list of card object. Just like in real estate kick system, our real estate report was an array list of real estate records. Actually, I shouldn't have put that angle bracket there. It's confusing. So here we have array list, and then the generic thing that it belongs to is card. And I have another special programming tool here, which is called tape, which I use all the time. Now I'm showing you guys how I actually really design programs. If I had a piece of contract IT work and I needed to design a program to do some job, I'd be doing exactly what I'm doing now. At the beginning, when I'm just sort of thinking how to manage the data. Now, besides an aggregation, a collection of cards, and one card object, what do we probably need here? Well, actually, I do have some different colored cards. We probably need a player, right? If we didn't. All right, guys, now that we've seen pretty much from beginning to end of this, let me just wrap it up a little bit here. So remember what we said, and this is for your assignment, which is due next week, which basically just take the starter code I gave you and just finish it to implement all of our Java classes, which are our UML entities. So we figured out that we need a class to be in charge of the whole game, and we need a dealer, and we need a card deck, which is an aggregation of cards, and we need some players. And the way it's going to work when we get to the project is there will be 3
computer players, which are objects which will run via algorithms that you set, and there will also be a human player which will interact via the command line. Right? So you do that, and then we drew this out, and we saw that this was our entire application. Yep. So here on this paper we drew UML entities, and we discovered what these are through playing around with our cards through our mechanical model here. So we have our game, and that Java class needs references to a card deck and to a player. So over here we have a player, and a player has a hand, and a hand consists of cards. Now, do you want the hand to be a separate object? Should that be a separate object? I don't know, maybe. That depends on your design. We're going to see about that. But since it occurred to us, let's write a little note to remember that. So we'll say design questions, should hand be its own object? So a hand is just like the 5 cards that the user is holding on to. And aside from that, so now let's trace this through from the beginning. So it starts with the FizzBin game. We have a card deck, and card deck owns the cards, and we have players. So that should be a card player, I think. Oh, actually, that's my player. And that, why do I have cards there twice? Let me go back and clean this up. And this is the purpose of doing this design, because we want to think through this before we actually start writing code. So let's think about the logic of this. So card deck, card player, well, this is actually a card player. Maybe when I went through this initially, I wrote this wrong, but again, we can fix it up easily, much easier than fixing it in code by scribbling some stuff out. So a card player has a name, maybe they're like Joe or something, and they have a hand, which is a set of cards. And a behavior we need to park here is the player will need to decide which cards to swap in each round of play. Now, where are we going to manage the concept of our rounds of play, do you think? Oh, I see. Here, this was with an S, because I didn't write the S strongly enough, so now I remember that this will be an aggregation object, and by drawing that line, we create a compositional relationship between UML. So now I remember what I was doing. And we also probably want to have a housekeeping class, which is going to do things like generating players, creating a connection to our database if we want to wire this up to a database to remember the state of play. And setup is where we're going to park behaviors such as setting up our game, doing the initial deal, right? So yeah, I don't think, looking at it right now, I don't see that hand needs to be its own object, because hand is not really managing very much. A hand, you know what I mean, right? Like a collection of 5 cards or something that each player holds. A hand is going to be a collection of cards. Maybe we could make that like a set or a map in terms of our Java data structure. We'll see that next week. I think it could be probably a set, because a set is every element has to be unique. So probably a set is the reasonable data structure there. But hand does not need to manage any decision making, because the decision making is going to be done by the player, right? So here's a card player, and here's a collection of all of our players in the game. So it's going to be an array list of card players. Is there anything else we need to do here? And I don't think so, because I think we've captured it all. Now we can go back one more time. We can look at our cards and see if there's anything we missed. So remember, we still need to figure out the rules of our game when we put this together for the project. We'll do it later, but we don't need to do it now. So at the highest level, we have a FISBin game. And a game has to have a dealer, and the dealer manages the card deck, and the dealer manages the player, and the dealer has to have behaviors such as managing each round, right? Each round of going around and asking player, do you want to swap any of your cards? So we can park a behavior here in dealer called manage rounds of play. And we already did that, in fact. So what you're going to do for next week for this assignment, all you're going to go is, and you, by the way, you can change this. I encourage you to add to this or change it or move it around. If you can think of better ways to do this, then that'll be great. But if you want a good starting point, which we developed in class, we have 1, 2, 3, 4, 5, 6 classes, plus we have this little kind of housekeeping class over here. This is not part of our algorithm. This is just something we put there to make the Java setup part of the game work. So maybe set up database connection might go there. But that's not part of our algorithm, so we're not going to model this right now. This is something we think about when we're actually writing code to make the code work. Not part of our business algorithm, of our game algorithm. However, it is a good idea to just take a note on your UML diagram to remember that you have to take care of that at some point. So now let's just go, before we wrap this up one more time, we'll go back to our Java code. So what are you going to hand in for the assignment? You're going to hand in a picture of your team's UML diagram, and you're going to hand in the skeletal starter of your code, which we'll develop together next week, and that'll become your project. That'll be the starting point of your project. So whenever you hand in code, it's always good to comment it, to let me know who the team members are. And we're going to have a main application class. He's going to set up a FISBin game. In fact, I think we could do our other setup in here. So we don't need, now that I think about it, we already have this, right? This is going to be in our main application. So that does not need to be a separate program, a separate class. Right, so let's take a note on that. So does not need to be a separate class. We can do this in main application. Take care of these things in main application. So generate players, set up DB connection, and probably 5 or 6 other things we're going to think of before we're done. But for right now, we can put those there as comments. So then you're going to go through this one at a time. You're going to take each of these entities from your diagram, See, so far together we did the one for the Fizbin game. I'm going to do one more. Well, actually, I already started to do card deck. So what's card deck going to look like? Well, right now, the only thing we can think of is that it's going to be an array list of cards. Does it need to be anything else? That gets to the issue of knowledge principle, the data plumbing, the appropriate assignment of responsibility. Who is going to be in charge of knowing which card goes to which player? Well, probably the player will, right? Because the only thing the dealer is going to do is manage the activity of moving cards in and out of our card deck array list, right? So we're going to have an array list called card deck, and its elements are going to be card. So I don't think we need a separate container. So remember we said one of the purposes here of UML is to figure out which are going to be the containers we need for our data and methods, right? I'll put that in your PowerPoint. Maybe it's easier to read that than to figure out my messy handwriting here. Let's open up your PowerPoint again. So this is a summary of some of the things we presented in class. You plan out in advance in a UML diagram. You come up with all of the classes you're going to need to put your behaviors and data into. So plan out and name all the classes you'll need, and then you come up with meaningful names for data fields and algorithms.